Well, hello, everybody. My name is Langdon White, and welcome to KBE Insider. We should have significantly more attendees today because Slack is down, so we may as well consider it a day off. Um, so it's like between GitHub and Slack, if either one is down, we really have a hard time doing much. But welcome to KBE Insider, where we interview people who are kind of doing the work in Kubernetes to try to give our audience a sense of where we might be going soon, and where we're going eventually, and where they want to go, so that you have a better insight into where the project is going or whatever, so that you can make better decisions about how you want to invest in your Kubernetes infrastructure. Today, we actually welcome Peter Hunt from CRI-O. But before we get into that, I want to mention a couple things. First, it is Tuesday, TWOSDAY, for because it's 2/22/22 or 22/2/22, depending on what part of the world you live in. And which is kind of awesome. I've seen a number of people who are also 22 today, which I think is pretty awesome as well. And then the other thing was the call for proposals, which is basically like submit an abstract so that you can give a talk for DevConf US is now open. I will throw the link in the chat, but the CFP is open if you are new to presenting. This conference is specifically geared to people who are, for the first time wanting to present. So we guarantee a soft crowd, and but it is all open source and all very techy. So check it out.
And is that going to be in person this year, Langdon?
It is currently planned to be in person. So everybody, let's make that true by trying.
So in Boston for our audience.
Oh yeah, sorry. There's only one place in the world, which is Boston, which is where I live. Right? So yeah, on the campus, and the reason I bring it up is I'm one of the founders of the conference. We've been running it. I think this will be its 5th year, but it's also on campus at Boston University, so that makes it more fun as well. So we strongly encourage you to submit a talk, and come if you can. It's August, I think, 18 through 20 this year. So, without further ado, why don't we get a little bit more into the show? And so, like I said, we'd like to welcome Peter Hunt for CRI-O. And if you wanted to introduce yourself, because as my long-running joke is, it's impossible to remember or know the team names or titles at Red Hat for any period of time longer than like 3 months.
Yeah, hey, thanks for having me on. My name is Peter Hunt. I'm a senior software engineer at Red Hat. I'm currently working on the OpenShift node team, primarily focusing on CRI-O and sometimes a kubelet and sometimes Run C and other container-related technologies.
Cool. And how long have you been working on the project?
So I was assigned, I was moved to CRI-O full-time basically 3 years ago. There was a period of time where I was kind of in between Podman and CRI-O, but I've been working on these things for like 3.5 years now.
Gotcha. And for many people who are involved in this space, what exactly is CRI-O? And what's it for? Because as a consumer of containerization stuff, right, I don't run into it very much.
No, it's not one of the buzzwords that come up very much, and that's actually partially like we kind of intend that. The idea of CRI-O is to be the implementation of the Kubernetes Container Runtime Interface, or the CRI, and an OCI Open Container Initiative implementation of that. So that's where the name comes from, CRI-O. The idea of it is before time, many years ago, when Kubernetes was first written, Docker was written directly into Kubernetes, and it was interfaced with the Docker shim, which is now being removed in 1.24. And but the developers of the kubelet wanted a way to kind of abstract out the way that the kubelet asks some entity to create the containers, pull the images, and like manage the pods. And so they created the CRI, which is a protobuf API to talk to some server and do those things for the kubelet, delegate out that job. So CRI-O is an implementation of the CRI, and we try to make it be as secure, performant, and boring as possible. We think that running containers in production you shouldn't really think about it. You should just install it on, and then it should disappear into the background while you do more important work.
But one thing I want to make clear, right, is, and I think by its name, this was actually a mistaken assumption I had a number of years ago now. It's not a reference implementation, right? It's meant to be a production use implementation.
Right. Yeah, and there really isn't there are basically two main implementations of the CRI now, CRI-O and Containerd, and they're both kind of tested in upstream cube, and they're both used in production. And so from the SIG node perspective, they're treated, generally equally.
Gotcha.
Just for our audience, you want to let people know what SIG node is responsible for?
Sure. Yes. So SIG node is like special interest group node. It basically is responsible largely for the kubelet. So anything once the API server asks the kubelet to do something, it's like the node level, okay, schedule this pod, and then the kubelet goes and delegates that work to the CRI implementation, does all the volume plugging, and yeah. So the work that's done, after everything's been orchestrated, once it hits the node itself, that's SIG node's purview.
Gotcha. Did you, you kind of opened the can of worms there, which we know is a hot topic in kind of the Kubernetes and actually containerization community in general. But before we get into the details of it a little bit, what I'm referencing, of course, is the Docker shim. What I'm curious about is, could you explain what the Docker shim does exactly?
Sure. So basically, the Docker shim is like a shim between the kubelet requesting, hey, can you pull this image, and then can you create this container, and can you create this pod, between that and the Docker API. So it's the way that the kubelet speaks Docker, and the way that Kubernetes used to run, because everyone used to speak Docker. The Docker API was the way that containers were created.
And part of the reason for the Docker shim is that Docker itself was designed to be a complete system and not a component. And so it required some hacky code to get it to behave like a component.
Yeah, that's a great point.
Right. I mean, I think it's one of those English words that not a lot of people are familiar with, but is exactly what it means when we talk about it in tech speak, right? Is a shim is something kind of like you shove it in there because you need it to, make something fit, right?
Right.
And so the other shim that I find kind of scary is the boot, on the bootloader with Linux, for example. There's also a shim. But so the Docker shim, the plan is to remove the Docker shim so that we can avoid this kind of indirection or this potentially hacky code or whatever. And then replace the container runtime with, say, CRI-O, for example?
Yeah. So once the Docker shim is removed, so for many years, the kubelet has been able to use the CRI to create containers instead of the Docker shim. So the idea of removing the Docker shim is to say definitively the CRI is the way to have your containers be created. So you have to use one of the reference CRI or one of the CRI implementations going forward.
Right. Okay. And so what will that mean for a user, like, a consumer of Kubernetes?
So so if you're building your own home cluster, or, you're running your stuff in production, you'll have to change some flags in the kubelet, basically say, hey, talk to the CRI instead of the Docker shim. And you'll have to run CRI-O on that node. That should be most of the work. So we hope, obviously CRI-O doesn't speak the Docker API, and CRI-O is made for the needs of the kubelet. So there are some things that CRI-O decidedly doesn't do that Docker did, like builds. But for the most part, if you're just running on your Kubernetes node and you drop a CRI-O process on there and tell the kubelet to talk to it, then it should just work.
Right. Okay. All right. So in the kind of an existing installation, you might have to kind of think about it, but in a new installation, it would just happen.
Yeah.
Right.
Right. Exactly.
I got
So
you.
what is, since you work at Red Hat, so what is OpenShift using currently?
OpenShift is using CRI-O. So OpenShift, CRI-O has been an option in OpenShift since OpenShift 3.11. And then for the entire 4 series, it has, which has been out for around 3 years as well. It has been CRI-O. So there's no other container runtime interface implementation that's been supported on OpenShift. Okay.
So OpenShift users are going to be unaffected effectively by Docker.
Yeah, exactly. They definitely. We've been using it for a long time and had a hand in kind of tweaking the CRI and building it and making it, production ready as it is today.
Okay.
Gotcha.
So say I actually have a cluster that's currently running on Docker shim, and I'm planning to upgrade to 1.2.4. Are there particular reasons why I would choose CRI-O versus Containerd?
So we think that a container, the container engine, like the high-level container runtime, sometimes called, should be, if it's used in production, it should be hyper-focused on that production use case. So CRI-O is able to make some design decisions because it knows it's only tailored for the needs of the kubelet. So it has some optimizations, but it knows the kubelet does a lot. It reduces the capabilities of the containers because we want to run containers secure by default. And had another point. Oh, and the set of things that CRI-O is capable of doing, as mentioned before, builds. Also, it can't push images. These things the kubelet doesn't need it to do, so it doesn't even think about it. And that reduces CRI-O's code surface, which theoretically reduces security risk as well. So it basically tries to be simple, performant, secure, and boring. And that's usually the pitch that we give. Like there's a couple of concrete cases where we know exactly how the kubelet is going to request a container be created. And if something goes wrong along that process, we know exactly kubelet's going to request that container be created. And as a result, we can optimize for that case and make sure that, try to make the containers come up as quickly as possible. So that's like one kind of a little more concrete example of like where we can optimize.
And Containerd is more generic, or?
Yeah, so Containerd, I mean, they call themselves like the generic container runtime. So in addition to tailoring themselves to the needs of the kubelet, they also have to support Docker, and they support a handful of other clients. So the code base is larger and their capabilities are more robust for sure. But we don't think that if you're running containers in production with Kubernetes, you need that robustness.
Gotcha. I was going to back up a little bit just because one of the things we like to kind of ask people who come on the show is what got you into open source in the first place?
So I have been using Linux since I was a freshman in college. I got convinced by a friend that it would be easier to do my coursework on Linux because all of it was Unix-based and I was using Windows at the time. And I switched over and I never looked back, using Ubuntu at the time, much to the chagrin of some of my interviewers. But So I spent college running Linux, but I never was an open source developer. But once I took, operating systems course and I liked it, I, figured out that there was a Red Hat office, close enough to where I wanted to live. And it just felt like a perfect fit. And I, applied and got a job as soon as I could. And so I was hired to work on Podman initially. And that's what I did my internship for. And that worked out well. They seemed to like me enough. So they pulled me back and moved me over to work on CRI-O. And that's where I've been ever since.
Oh, well, now until we have to ask. So what Red Hat office was that?
It's in Westford.
Oh, okay. I gotcha. So formerly the Boston office,
Yes,
mind you, Westford
until they
is
made a real
45 miles, I think, from actual Boston,
Right.
where I live. But now there is the downtown Boston office. So there is an actual Boston office as far as I'm concerned.
Right.
So, okay, so that got you kind of into open source because you started using Linux or whatever. And as a contributor, you got pulled in because you started to get interested in operating systems. Did you have that, what they refer to as like the open source, now I can't think of the phrasing, but like that itch where you're like, this thing's really bothering me, so I'm going to go fix it. Did you have that moment as well?
There definitely were a number. Yeah. Oh yeah. I mean, not so I wasn't great about, contributing things upstream, but it was very special to be able to, dig into, the display manager and be like, I want it to look like this, or I want to do this. I definitely bricked a number of my early installations trying to customize it too much.
Yeah, I know that feeling. I had a deep fear when I was installing Slackware on a computer in my dorm room that it was going to literally light the monitor on fire, which was something that used to happen fairly often, but has gotten quite a bit better.
It was easier when I started. Yeah, definitely.
Yeah.
Just put Ubuntu on there, and much simpler.
Cool. And so, what is your role on the kind of CRI-O team or on the node? What do we call them in Kubernetes working group?
SIG.
Yeah, the SIG.
SIG. Yeah.
So I mostly maintain CRI-O. I would say like 80 to 90% of my time I spend thinking about the CRI-O code base. So I serve as one of the primary like triagers of CRI-O issues and the pushers of CRI-O features. There are plenty of like features that this SIG node ends up, working on that, both of the CRI implementations have to work on. And so I'll often find myself, working on those. And then I spend some of my time in SIG node thinking about developing, moving forward the Kubernetes ecosystem with the features in the kubelet. But yeah, most of my time I would say, and then I spend a little bit of my time maintaining Conmon, which is a little agent that each container runs or needs to run, that runs each container and pays attention to its logs and its life cycle. So I also maintain that.
Is that like the pause container? Like, is it running in the pod or
no? So it's on the, so it's between CRI-O and the container. So it's the entity that actually spawns the runC process. And once it does that, it like attaches to the standard out of that process and forwards the logs to the disk so that the kubelet can read them. And then also like watches for SIG child. So when the process dies, it can write its the exit code to a file that CRI-O then reads. So CRI-O can actually shut down. And because none of the containers are actually direct children of CRI-O, none of the containers die. CRI-O can shut down, configuration can change, it can come back up, learn that all of these containers are still up, and then basically just like remember all of the state of the node.
Yeah, that's been I have very close experience with that with like libvirtd. You know, kind of same idea is like, you know, you can launch all the things, and then for whatever reason, if you have to shut libvirt down, you can do that and then kind of bring it back. Just, you know, the reason I mentioned it, right, is I think developers in general probably have more experience with being that close to your virtual machines, whereas you know, with the containers, I think it's less common. But that's why, you know, I would say it's comparable. Sorry, Josh, did you have something you wanted to ask?
Oh, well, you're mentioning on working on some features and that sort of thing. So, so you're talking about the job of CRI-O is to be boring and that sort of thing. But I seem to remember from KubeCon that you are actually working on adding some new things to CRI-O, things that actually might not have been available via Docker.
Well,
in
yeah.
previous
So, you know,
capabilities.
we tout the boringness of it, but you know, still at the end of the day, people want to get work done, and often this work ends up being interesting and novel. And so there are situations in which we add, you know, we do add features to CRI-O. So some of the things that we're working on, yeah. So you mentioned the KubeCon talk. There's some situations where there are resources on nodes that need to be provisioned for containers that the kubelet isn't aware of. Like, it's kind of a hard thing to get fields into the pod API because like a ton of entities think about the pod API. So kind of like a ground level thing to add support for, like things like specifying the size of the shim for the pod, which is how pods, you know, can share memory, or you know, there are some experimental resources on the node, like Intel's block IO configuration. Like these things, we've added support for basically specifying an annotation, which is something that Kubernetes supports very easily, like just, you know, arbitrary string key values. So, you know, a user can specify a special string in their pod, and if the admin has you know, turned on a switch and that user is able to make a pod with that certain annotation, then they get access to some of these special features like that. So things that we're thinking about just generally is, you know, Kubernetes has kind of worked in a certain way for a long time where it, like the kubelet basically does this like list watch loop where, you know, because before in Docker, it basically was just like, hey, what are the containers I have? What are your containers? What are your containers? What are your containers? On a loop to actually get the state of the node, because it was like kind of a hacky, you know, shim, as we were talking about. So now we're kind of imagining what the future could look like, and thinking about like, okay, can we wire up, you know, events in, you know, the kubelet so that it can listen to events and reduce the like runtime CPU usage. And then following a couple of caps upstream, we're working on reworking the way that stats are gathered. So I'm sure that this will come as a shock, but the way that stats are gathered in Kubernetes is also kind of hacky, where it used to be that cAdvisor would monitor the behavior of the Docker containers by, you know, notifying on C groups hierarchy. So basically, whenever a new C group was created, it would be like, ooh, a new C group, and then go and look at the hierarchy and be like, okay, here's what the memory of that process is. And so it kind of has worked that way, even as new CRI implementations have been created, which has caused a lot of code bloat in cAdvisor. And it's actually made it kind of hard to maintain, because it knows like a ton about all of these different, you know, CRI implementations. So we're working on moving the stats gathering from cAdvisor to the CRI implementation, which has a couple of, you know, little difficulties about it because of the way that it has worked always. It's hard to change things with such a large and slow moving project.
Gotcha. That makes a lot of sense. So kind of expanding on that though, if you were in charge of the world, what would you like to see next? Like, what are the things that, like I said, infinite time, infinite money. What would you think that the right, direction in a sense for Kubernetes, or even CRI-O, or any part in the middle?
So I would love for a world, and most of my worldview is focused on Signode. So I would love a world where the kubelet was was the process pretty much responsible for what it's doing now. It listens to the API server and then calls down to a CRI implementation. I would love for the CRI implementation to actually be a very thin proxy to basically one that basically runs all of these per pod processes that actually are responsible for delegating the work needed for that pod. And when a container dies, it would emit up an API, an event up through the proxy and back to the kubelet. So basically, like, the CRI piece would be much thinner and much smaller, so that the runtime CPU, there wouldn't be all this listing, there wouldn't be all this like process just waiting for stuff to do, but rather it would, all of the little processes would be responsible for their little piece of work per pod, which would allow Kubernetes to scale up and scale down, much better. Like, Kubernetes has a lot of trouble with the single node or like the, smaller box. It's really like meant for like, okay, I got a huge cloud server with a bunch of VMs and let's run, these things in the VMs with this elastic amount of resources available. So thinking about what it looks like for a tiny little server to run, these containers, and, how, what the memory and CPU constraints would look like, it would be great if it was more flexible, and not as, it's kind of like wasteful now, if being frank. But obviously it's worked this way for a long time and it works well. So it's hard to change. So,
right.
I would like to live in that world eventually.
Right, because you would have to change kind of both sides of the problem, right? And obviously changing the kind of almost like the Kubernetes side of it is quite difficult at this point, I imagine.
Right. So my hope is that, we haven't yet put up our proposal, but we're currently, like, some folks at my team at Red Hat are imagining what this proposal would look like. And then once we submit that and it goes through a couple of releases, then, for the proposal for the event driven. So that's like the first step. And then once we have event, then we can start thinking about, okay, what actually does CRI-O need to do all the time? What is this daemon that we're running? Do we need it? Or like, how can we pare it down? Another, thing that we're working on that I forgot to mention is we're rewriting Conmon. We mentioned Conmon earlier, the container agent. We're actually rewriting it in Rust, the new hot language that everyone loves talking about. And we're updating it to, right? And and we're updating it to a per pod model rather than a per container model. Right now, for every new container that's created, a new conmon is running. For every container exec that runs, a conmon runs. And all of this is, more processes than are actually needed. So we're hopefully in 124, we'll have a preview of this, Conmon 3.0, which is, a per pod Conmon that CRI-O can talk through, through an API. And, so that will also take us another step forward to this world where that process can actually be responsible for calling all of the run C create, run C exec, run C kill. And then eventually, we can start paring down the things that CRI-O needs to do and have it just be as focused as possible.
I sense a lot of debugging in the future, particularly for things like exec.
Yeah, it definitely, and it's kind of funny you mentioned it, because it's as if Kubernetes needs more complexity and as if it needs, to have more processes in the picture. But you trade-offs everywhere, and we'll have to make it easy to debug. Conmon 3.
But sorry, maybe I misunderstood. But in the proposal with Kanban, then wouldn't kind of the number of things happening actually be reduced, or do you think they would go up?
So
if you're doing it by pod versus by container,
there will be fewer processes, but Kanban will be more complex.
Gotcha.
It will be doing more things, and there's like currently a pretty there's CRI-O, which is a tool that can speak the CRI client language, so it can ask, hey CRI-O, like what are the containers that are running? But that doesn't exist for this new agent that we're making. So there's it will have to think about how best to see into the world of Kanban.
Right.
As the scope of Kanban increases, and because like I imagine a world in which it basically CRI-O is like, okay, I have this pod, I have this I need a pod with this specification, and then Kanban does the namespace pinning. It acts as PID 1 for the container for the pod if the pod is a private pod level PID namespace. Which is the reason for the pause container, which you mentioned earlier. So we'd not need the pause container in like most situations. And then it like sets up basically all of the containers and does all of the execs, can stop the container when it's asked to. So basically, all of the functions that CRI-O is kind of doing, moving it down to the pod level one day.
Into the combine.
Mm-hmm.
Right. Gotcha. Sorry, Josh, did you have something else you want to ask there?
I am interested in one thing, which is that if Kanban's being rewritten in Rust, then was there like sort of internal debate about that? Because obviously you're rewriting Kanban in Rust, and at the same time you're having it take on more work that's currently being done by the kubelet. So yeah,
the basically so the options were rewrite or like extend the behavior of the current Kanban, which is written in C and has been put together over a time, like over long enough, and like the main developers have kind of cycled in and out, such that like I'm like one of the main contributors of it, and it's hard to work with. So it was either that or rewrite in Go, which has a lot of limitations with respect to memory usage. Like the Go runtime is very heavy, and the garbage collection is expensive, especially if we're trying to reduce like latent CPU usage. So kind of like Rust lived in this world where it was like it could be performant in the way that C is, but also is a more high level language, easier to work with, can have like threading very simply, can have all of these niceties that we're used to in now. So
I guess I didn't realize it was not in Go, so that makes more sense, right? I mean, if you're
whole
if you're going from C
world is kind of in Go. Yeah, so that's I mean it has been very useful being in C because it's very low, very low memory. Even for per container process, it's like 2 megs per container. If there's like a couple of containers per pod, that's pretty low overhead overall. But so it's a fun secret is that we have Kanban in C, which is
Right. So that makes a lot more sense. I mean, I at least for me, if it was in Go and going to Rust, that's a much harder decision given, as you were kind of saying, right? Most of the Kubernetes world is in Go, but I think if you're coming from C, you have a lot more, options there. We did actually have a question I was just going to bring up from the audience, which was, is there a plan to coexist with the 2 versions of Kanban as it comes out? Or, are you going to try to do a forced move, or, how do you how do you think that will happen?
Right. So my plan. So right now we have the ability to toggle between runtime types because we have support for Kata, which is a runtime type of VM. So you have to kind of work with it in a very particular way, and then the runtime type OCI, which is just like a Kanban based. So my plan for this would be introduce a third runtime type, of which has yet to be named, and then they. And long story short, they would be coexisting for a while as we work out any issues with the new Kanban, and we have a normal, because like CRI-O supports the 3 Kubernetes releases that are currently supported. So we would be supporting a Kanban based one for a while anyway. So where we'll safely move through until we're ready that it's like up to snuff and capable of handling the production workloads in well.
Oh, we just lost your sound, Langdon.
Sorry, is that better? If I don't hit the mute button, it also works better.
Yes.
Sorry, I coughed earlier, so I didn't want y'all to have to hear that. I just said that's Kata, as in Kata Containers, right?
Correct. Yes. Sorry. So yeah, Kata Containers, the concept of running a tiny little VM instead of for a pod instead of a set of containers.
Right. Yeah, I just wanted to make sure that we were talking about the same thing.
Yeah, and I guess it would be like how would one of the things is how would it affect more exotic things, right? Like KubeVirt, for example.
So I mean, KubeVirt, KubeVirt is, from my understanding, and I haven't really worked a ton with KubeVirt, but I've supported a bit of it. And from my understanding, it's basically like they create a privileged container process that then talks to libvirt directly, and that creates a VM. The VM, it doesn't really live in the container root as mine, or maybe it does. I'm not super familiar with like exactly.
No, it doesn't. It doesn't. It kind of emulates a pod rather than being
right.
one.
So theoretically, I mean, everything that you can, because a container is just a process on the host that's in a root environment. So anything that doesn't change very much. Really, what changes is like the way that we look at into those processes. So like Kanban is the thing that's like listening to the standard out and running it to disk, and monitoring the exit code. None of that changes if the configuration gets a little bit more exotic. For like something like Kata, where the container is actually a VM, or the pod is actually a VM, and inside of it the containers are running inside of the VM, that we're not really considering within scope of this change, because the Kata community has there's a very particular way that they interface with CRI-O, so we're not really messing with that. So this is for run C or like C run type containers that are processes on the host that are run inside of a root environment. Those will be within scope of the change.
Gotcha. You've been talking a lot about change, and one of the things that's been coming up for me a lot as a faculty member now, right, is where if somebody wanted to get involved with the project, either CRI-O or Kanban or whatever, I would imagine that there's that it's kind of got a bunch of code that is kind of small, in the sense that you can understand a small amount and make a fix. Are you tracking anything like easy bugs or easy fix type stuff for where I could point people to go and try to get involved in the community?
Yeah, it's a great question. So we do have in CRI-O, we have like a couple of tags like good first issue and help wanted. So those we try when triaging to apply if they seem generally pretty small in scope and something that wouldn't be too complicated, but we ourselves don't really have time for. So yeah, and I mean generally we're always happy to help people find work that they're interested in. So if they wanted to reach out to any of the CRI-O developers, we largely live in the Kubernetes Slack in pound CRI-O. So if people wanted to, wanted to learn how to contribute more, definitely reach out to any of us, and we'd be happy to kind of direct them. We're always looking for new contributors.
And where's the Kanban effort? Is that also run in sort of in the CRI-O community?
So right now, yeah. So we're the CRI-O community, the Podman community will soon join the effort. They've been focusing on a new major release. So, but they're going to soon join as well. But yeah, it's largely right now it's just a couple of developers on the CRI-O team, and that is right now. It's still we're still pretty early stage. Like we're pretty close to a MVP, but there's still a number of steps, and a lot of us keep getting distracted. So that lives in you can talk about it in the CRI-O Slack or on CRI-O, and the repository is github/containers/conmon-rs. I have access to the chat. I can type that out, but but right now it's such early stage that we haven't really started, working that concretely on the integration into CRI-O.
Yeah.
Yes,
I was just thinking because a lot of particularly young developers who are just leaving college, right, are learning Rust, and so they're going to be interested in that. I'm just like, if somebody is a Rust developer and they want to get involved with Kanban, where would they go, right?
Yeah, and I do think that, speaking of the future a little bit, I think that the future of some of this, cloud native, Kubernetes world is rewrites in Rust. I mean, Go is a great language. It's has a very low barrier of entry, and it is very clear what code is doing, even very complex code. But I think that for processes that live in the world that CRI-O lives in, like the container manager, when you start actually really tangibly thinking about the processes of a container, something a little bit more low level, something a little bit more conservative about memory, I think will kind of be the future of. I mean, we've been joking about wanting to rewrite CRI-O itself in Rust for a long time, and that we're kind of reconsidering that. But as the future goes forward, I can see things like that happening more and more.
Well, the reason, kind of another experience I have that kind of reinforces your opinion in my mind, right, is we've been looking in the university, right, at needing a low-level language to teach low-level classes, right? So like an operating systems class. This was specifically in the data science space, but whatever. And to try to get away maybe from C and C++, and and it looks like Rust might be the best choice for that, right? Is that it needs to be low enough level, and I also think that Rust starting to land in the kernel, like in the Linux kernel, maybe not quite mainline, but certainly nearby. Kind of also reinforces that opinion, right? So, but I think one of the really nice things about modern development, the last 5 or 10 years, with the popularity of containerization and all that jazz, is you can choose the right language for the right job significantly more easily than you ever used to be able to. So, just because you have, one thing written in Go, another thing written in Rust, and another thing written in C, yes, you need to think about making that decision, but if there's a good language reason, it's very doable now.
Definitely,
which is nice. Did you have something else there, Josh, or did you?
No, we're just Well, do you mind if I change topics completely here?
Oh yeah, go ahead.
Are you still doing competitive dancing, Peter?
No, the last couple of years haven't been the most conducive for competitive partner dancing, but and I did last competitively dance when I was in college. I was a competitive ballroom dancer, so but I've kind of fallen off a bit, but I am interested. as it becomes safe and poking back into the world, at least casually. I don't think I'll probably remain a competitive dancer, but yeah, I definitely
classic ballroom dance like waltz and that sort of thing.
Yep. Yeah. So like in the waltz, tango, foxtrot, and then also the like Latin dancing like cha-cha and rumba, samba and jive. So
have you considered a TikTok channel? Because that that would be an appropriate landing point for significant amounts of dance.
I think I've forgotten a lot of the stuff, and so I would have to get good again before or get better before considering avenues of advertising my skill.
Right. So we did actually just have a question in the chat, which is that are you seeing other parts of Kubernetes that are typically in C or whatever moving towards Rust? Or is Conmon kind of a just a one-off and unrelated?
I don't actually know of many other projects written in C. I know isn't Envoy written in C++? I'm not very tuned into that community. But or one of anyway.
I want to say Envoy it's either C or C++. I can't remember which though.
Yeah, well, I know isn't the new linker D is Rust, yeah?
Oh, that's possible. I don't know. But I think a lot of the conversation will end up being what to move from Go to Rust, because Go is clearly the dominant language in this ecosystem. And I mean, I think things like, I don't know, like, for instance, thinking about the prospect of rewriting the kubelet is horrible and makes me scared, because it's like, hundreds of thousands to millions of lines of code and incredibly complex and not super well unit tested all the time. So I don't know, like, for a lot of the pieces in the like higher level Kubernetes ecosystem, I'm not sure if it makes a bunch of sense. I mean, obviously it's very modular, so if like some really motivated developer wanted to go and rewrite etcd in Rust, they could and just plug it in and it would work. But I think that the biggest considerations are like, anything underneath the kubelet. So like rewrite, like, there's the project C-Run, which is written by one of our colleagues at Red Hat and Giuseppe Scrivano, and like C, like, so it's run C rewritten in C, which makes sense because it's, nice and low level, and you need access to a lot of the kernel APIs, and there actually are pieces of run C written in C to do some of the things that Go can't. So for positions like that, like I can imagine a world in which someone would, I mean, there is actually a Rust runtime, and I'm forgetting the name of now, Yuki or something. Yeah, Yuki. But I think that like it's like the container manager level. So like, CRI-O or Conmon or, maybe run C are the most clear targets for that kind of rewrite.
Gotcha. Yeah. I mean, I think that's interesting, because language choice can make a big difference to, the kind of situational or, the situation or whatever. But Rust really, it's only, in my opinion, right, it's only just getting to the point where it's something I would trust at that kind of level. It's great and all, and people can really like it and all that jazz, but it's like, if I'm going to run something in production,
I was gonna say, I don't know. I was a C programmer for a long time, and just because a language is old doesn't mean it's trustworthy.
Well, that too, right. I would make that argument about C++, but yeah.
Well, and I think, I think the barrier to entry of Rust, I mean, at least speaking for myself, like changing the way that I think about programming models and, making, to the Rust version, like it's not like, we have some of it, some of that model in C++, but it's not mandated in the way that it is in Rust. So I found it hard to switch over from Go to Rust, and I can definitely see that being just a general barrier of entry for any project thinking about moving over to Rust.
Well, I mean, one of the things you always have to look at is you look at the programmers who have a track record, and you look at the programmers who are new, right? And I'm seeing a lot more Rust adoption among new programmers, because if you look at, I mean, you still look at the Go documentation, it starts out with Go is just like C, except for these things.
Yeah.
Which is great if you're like me and you've already programmed in C. But if you're getting started, or you're crossing over from Java, that's not helpful at all.
Right.
And and in the world of code, we always have to think about the fact that there's always more new programmers than there are old programmers.
Yeah, like speak to anybody who's still raking in the bucks for COBOL, right? So there was a question in the chat of like advice. I'm sorry.
Go ahead.
Oh, I was going to say somebody asked if there was advice on learning Rust, and at least for me, I when I started to take a look at it, and I did not get very far because work kind of got in the way. But the Rust kind of website is pretty good, at some of the kind of documentation tutorial stuff. But I was wondering if either of you have anything that you've heard or seen or experienced that seemed like a good way to help you learn Rust.
I learned it very kind of, I don't know. Books don't typically work for me. My brain, I try to read and I just get hazy, have trouble paying attention. So I don't have any suggestions like that. What I do is I look at code that other people have written in Rust that I trust. So one of my colleagues, Sasha Grunnert, who also works on CRI-O with me, he's done a ton of writing stuff in Rust. And so I basically look at his code and then see how it looks, and then write some code and then see how many compile errors I have, and then Google all the compile errors until I fix them. And eventually, iteratively over time, I start getting more familiar with it. But I don't think that that's actually the most efficient way to learn a language. I think that's just like the way that works for my brain. So
Yeah, it's funny. I actually, I'm very good at reading. Like, I really like reading or whatever, but not to do something like learning a programming language. I usually find the best way for me to do it is I try to go build something. And, and basically, Stack Overflow in Google are open over here, and my, text editor is open over here, and I just kind of keep banging at it until it works. But I think that's there are better ways to do these things. I'm just not 100% sure what they are. But I did like I said, I like the it's Rust. I can't remember the website. It's like rust-lang.org. Yeah. I like some of the content there. I thought that was pretty good. And isn't like Firefox is now completely Rust, right? Or is it just like a Rust engine? But I mean, I would trust that code as an exemplar. I would think,
Definitely. Yeah, I agree. Yeah, that there's a lot of, I don't know if all of it, but I know a lot of it has that was a lot of Mozilla's motivationing,
for creating it. Right?
Was, yeah.
Right. I was just looking. I feel like Sasha is going to be on the show in the future, right?
Yeah, he is actually. Next month, I believe. Yeah.
Yeah, so I was just looking because I was like, do I have the right Sasha? I can't remember now.
No, I'm just trying to remember whether it's next month or the following month. Let's see. No, it's next month.
Okay, cool. So
no, not next month. I'm sorry, it's February now. No, Sasha is April. So Sasha's going to be on in April talking about SBOMs and release artifact signing for Kubernetes.
Gotcha. All right, so we are almost out of time. So, but I do, on behalf of Twitter, have to ask about the floral pants, just on principle.
Yeah. Do you have what about them?
Oh, do you own a lot of pairs of floral pants? Where do you come by them? Are they easy? Do you recommend them for others?
Absolutely. I 100% recommend. I find, I typically dress largely masculine, and I find a lot of masculine clothes don't have a lot of the flair that I'm looking for. So I shop in the often the women's section in thrift stores for fun pants. I've got some. I don't know if I can get my leg up here, but I got some up here.
Okay, there we go.
Calisthenics on KBE, right? Yeah.
So yes, but I definitely think more people should be wearing fun pants. I kind of really have a thing against jeans, and so and the nice thing about the fun pants is that they're also comfortable, which is a big thing for me as well. So definitely more flowers in more places is my review.
See, I would struggle with, because you mentioned that they tend to be women's pants. Jeans already don't have enough pockets for me. I can't imagine losing even more because of the corruption of lack of women's pockets. Which I think is a horrible thing you could fix too. But
yeah, now I actually have pairs of floral plants. This is my summer weight pajama pants for working at home. Are largely floral prints.
Nice.
But those were actually out of a catalog for the men's casual pants has exploded as an industry over the last 2 years for some reason.
Yeah. I definitely, I feel like they're still niche enough where they're like more expensive than like I'm looking for.
Yeah.
So, and I definitely saw, looking.
These were not.
Okay.
But you know who wears really flashy pants, and it's people in the culinary industry, back of house.
Because that's true.
Chef pants are a thing, and those are expensive, but they're also indestructible.
Right.
So,
scrubs are going that direction too. You're seeing a lot of scrubs now that are in fancy flavors. It's funny because my father was a ER doc, right? And I remember growing up him basically wearing scrubs most of the time. And they were never anything besides green. Like ever.
Yeah, no, we bought my dad. My father's an obstetrician, and so we bought him a set that had little tiny prints of the chlamydia virus all over.
Nice.
Yeah.
All right. On that note, which thanks so much for coming, Peter. We really appreciate it. And we love talking about the low level things that are going on with Kubernetes. We like to hear from engineers who are kind of doing the work. What where do you see it going? That's really interesting about the Rust choice. Interesting about how you're trying to get more of an event driven infrastructure, even at the kind of CRI-O level, which I think is also interesting. But thanks to the audience. Really appreciate you sticking around for this. And please definitely join us. We already have, I think, guests lined up for the next 4 shows, something like that. So keep an eye out. Last Tuesday of the month.
Yeah, next month is going to be a couple of people talking about, I was mentioning more exotic runtimes like Kubert, so a couple of people talking about virtual machines in a container infrastructure. So somebody from the Kubert project, as well as somebody who's worked on virtualization in the Linux kernel for a long time. So
right. Yeah, so that should be a fun show. But just remember, it's the last Tuesday every month, 10 a.m. Eastern. What is that? UTC is 2 p.m. And and we'll see you next time.
Okay.
Thanks. Bye-bye.